everyone. In the series of theory of computation lectures, we'll discuss some problems, some more problems. Okay. So today we'll see one by one. We'll discuss problem statements and how to give the result for that, solution for that. First problem is they are asking to design NFA transition diagram for the transition table given below. So they have given the table here. So there are Q0, Q1, Q2, Q3. There are 4 states. Q0 is the Q0 is the starting state, Q3 is the final state, and they have given the transition Q0, Q1, Q2, Q3, Q2, Q3, and Q3. Okay, this is what they have given. So they are asking to design the transition diagram for this table. Okay, this is the diagram. This is the table given. Okay, from this table you have to give the NFA transition diagram. Okay, so in the previous lecture we were discussing what is finite automata and deterministic finite automata and non-deterministic finite automata, and now we'll design a NFA transition diagram for this given table. So first of all, you identify how many states are here. 4 states are here. You just make it as a states Q0, Q1, Q2, Q3. Okay, there are 4 states, so just to make it as a states. Now this is the by seeing this table you can identify that. So the arrow mark denotes the starting state, star denotes the final state. So you have to, we are just making Q0 as the starting state, and we are just by looking this table you have to come up with the diagram, right? So first Q0, on being on state Q0, by seeing symbol 0, seeing this input symbol 0, it goes to Q0 as well as Q1. So which means it goes to Q0 comma delta of Q0 comma 0, it goes to Q0 as well as Q1. So Q0 as well as Q1. So when you are giving 0 on the state Q0, it goes to Q0 as well as Q1. Okay, this is completed. And next Q0 comma 1. So when you are giving input 1 on state Q0, it goes to Q0 as well as Q2. Okay, Q0 as well as Q2. So I can make here 1 and Q2, right? So 1 here. Okay, this is over. And now Q1, on seeing symbol 0 on the state Q1, it goes to Q3. Okay, Q3. So you are giving the input on state Q1, it goes to Q3. Okay, so which means this is over. Here there is no move, so you will not be filling, you will not be making any diagram, and now any move, and now Q2 comma 0. So being state Q2, by seeing the symbol 0, it goes to what? Q0, Q2 as well as Q3, and then Q2 comma 1, delta of Q2 comma 1 is Q3. So being state Q2, by seeing the symbol 1, it goes to Q3. So comma 1. Okay, this is over, this is over. Now Q3 comma 0, self state, Q3 comma 1 again self state. So I will make this as 0 comma 1. This is the diagram from the given table. So now when you are giving the NFA notations, you have 5 tuples, right? Capital Q, and then starting state Q0, and then sigma input symbol, and then delta, and then final states. Okay, so now what is Q here? Number of states Q0, Q1, set of states. Okay, what is sigma here? Sigma 0 comma 1. What is delta here? Delta. So you have to define the transition function. To define the transition function delta, so which is delta of q naught comma 0. What is that? Q, they have given, right? You no need to write this one. Okay, instead we just make it as q naught comma 0. It goes to where? Q naught q1. Likewise delta of q naught comma 1, it goes to q naught comma q2. Likewise you can make for every states. And this is no need to write this one because we have already the given data is in the table itself. Okay, so and then you have final state f. What is final state here? Here q3 is the final state. Okay, and the diagram is, this is the diagram. Okay, this is how you have to present it. So when they are giving the table, you have to draw it like just by seeing that input table, transition table, just notice just have q naught comma 0 on 0 on being the state q naught. By say giving the symbol 0, it goes to q naught as well as q1. So we just make a move like this. Okay, so you are in state q naught, you are seeing the symbol 0, it goes to q naught. So just to make a self loop, and then it goes to q1. So you are just having the connection between q naught and q2, q naught and q1. Okay, likewise you have to draw this diagram. Okay, I hope you understood this one, and we'll go to next problem statement. Okay, so what they are asking, the problem statement for the finite state machine. So the second problem is for the finite state machine M given in the following table, test whether the strings 101101 and 1111, okay, are accepted by M. Okay, so the table given here is, this is the table, state 0 1 q0 q1 q2 q3. This is the starting state as well as final state. Here q0 q1 q3 q0 q3 q1 q2. Okay, so this is the table they have given. So now we have to find out whether these strings are accepted by this automata. Okay, final state machine. Okay, so now how will you check? You have to, we have already discussed what is language acceptance. When will you say a given string is accepted by finite state machine? So once when we are accepting, when you are looking the strings in the language. Okay, language is a set of strings, right? So when you are processing the particular string, it should reach the final state. Okay, so you will be starting from the starting state, and so first of all delta of, we are taking the initial state, that is here in this diagram, this table, the initial state is q0. So initial state, starting from initial state, you are just giving the input. Okay, so this is how we are taking this input. Now you have to find out q0 comma 1. On being state q0, upon seeing the symbol 1, it goes to where? q0 comma 1, it goes to q1, right? So you just make it as q1 comma 0110. Okay, this is how you have to write it. Okay, when you are writing here, you will be making this as a transition this is the symbol to denote transition from this state to this state. Okay, so now and then next, delta of q1 comma 0 on being state q1, upon seeing the symbol 0, it goes to where? Q3, right? So I will make it as q3 and I will remove this one and I will write the remaining symbol. Okay, and then you are being the state q3, on seeing the symbol 1, q3 on 1 it goes to q2. Okay, so q2, I am making this as q2 and writing the remaining symbol, and then you are being the state q2, by looking the symbol 1, q2 on 1 it goes to q3. So I will make q3 and the remaining symbols are 0, 1. Now you are in the state q3 and you are seeing the symbol 0, q3 on 0 it goes to q1. So delta of q1 comma 1. Okay, now you are in state q1, you are seeing the symbol 1, so q1 comma 1 it goes to q0. So it goes to q0. So now you have processed everything, there is nothing is there, thing is left here. So delta of q0 comma, nothing is left here, so which means it is epsilon, there is nothing, right? So I can make this as q0. Okay, so now you have to check whether the reached, you have processed the strings, the given string, and reached the state called q0, and you have to check whether the state is final state or not. If it is final, the input string is accepted. If it is not, then we will not say it is accepted. So now for this string, the string is accepted by this automata M because it reached the final state. Okay, the star means, you know what is star? Star means final state, it represents final state. So q0 means it reached the final state, so you will say the string is accepted. Okay, so this particular string is accepted by this automata, given automata. Okay, the string is accepted. Now we will take the another string, that is delta of, you will be starting from the starting state q0 comma, you are taking the input 5 ones. Okay, now you are making a move, you are being the state q0, upon seeing the symbol 1 it goes to q0 comma 1 it goes to q1. So delta of q1 comma, you will be writing the remaining symbols. Okay, and then q1 comma 1, so delta of q1 comma 1 it goes to q0. So delta of q0 comma, you will write the remaining. Okay, and then q0 comma 1 it goes to q1, delta of q1 comma 1 1, the remaining symbol is 1 1, and then q1 comma 1, so q1 comma 1 it goes to delta of q1 comma q1 it goes to delta of q0 comma 1. Now q0 comma 1 it goes to q1. Okay, it goes to q1. Now just to check it, now the strings are already processed, there is nothing is remaining, so you are in the state q1. So whether the reached state is the final state or not? No, it is not a final state. So which means that the string 1111 is not accepted. Okay, not accepted by the given final state machine. Okay, I hope you understand what I am coming to say. So when they are giving the transition function or a table and they are asking to check whether these strings are accepted by the given automata, you have to do like this. Just to start from the initial state and process the string on the symbol on the strings, and then you will be reaching one particular state and you have to check for the acceptance. So which means, how will you check? When the particular state, when you are reaching the particular state, you have to check the state whether it is a final state or initial state or some other intermediate state. If it is a final state, you will say it is accepted. If it is not a final state, you will say it is not accepted by the given automata. Okay, so I hope you understood these two problems. Okay, and then we will have one more problem now. Construct NFA for, I hope you understood this. We will have one more problem. We will have one more problem now. construct NFA for a language. Okay, construct NFA for the language L which accepts you need to construct NFA. Okay, I hope you understood what is DFA, and today we'll see what is NFA. NFA for a language L which accepts all the strings which accepts all the strings in which the third symbol from, please note down the statement, third symbol from right end is always A over the input alphabet sigma A comma B. Okay, this is what they have given. Construct NFA for language L in which accepts all the strings, all the strings in which the third symbol from the right end is always A. Okay, hope you understood the problem statement. In which the third symbol from right end, you have to note down the keyword, right end is always A. Okay, this is the statement they have given. You need to find out the NFA. So first of all, you have to understand what is NFA. So NFA means non-deterministic finite automata, where for a particular state you will have, when you are giving particular input, one particular input on the state, it will go to more than one states. Okay, that is called NFA, right? So I mean there will be like there is two more than one moves will be there for the particular input, single input you will have more than one moves. Okay, so now you have to know the meaning of this. You have to, this automata will accept all the strings in which the third symbol from the right end, third symbol, okay, they are telling third symbol from right end, this is left hand, this is right hand. So third symbol from right end is this one, right? This one, right? This one should always be A. Okay, this is what they have given in the problem statement. The third symbol from right end is always A over A comma B. So which means that there are two input symbol, either A or B. You can have either A or B. So but they are telling the right end, third symbol from the right hand should always be A. Okay, always A. So other than that, these three places you can make like either A or B. Either A or B, there may be a possibility of A or B. Either A or B. Here also you can have either A or B. Either A or B, but here in the third symbol you should have only A. Okay. So this is what they are asking. So when you're seeing this this thing, you will come to know how many number of states will be there. So there are four symbols, right? Four symbols forms a particular string, right? One particular string. So now just make 1, 2, 3, 4, right? 4 means you will have 5 states. 4, the length of the string is 4, means you will have 4 plus 1. This is the length of the string, right? 1, 2, 3, 4. 4 places you can have combination, right? Here, except here you can have a combination, right? So which means 4 plus 1 you will have 5 states. Number of states are 5s here. 5 here. Just name it as A, B, C, D, E. So now just connected. This is the starting state. This is the final state. So 1, 2, 3, okay, 4. Okay. So now here either A or B. Okay, first A or B, and then you can have either A or B. Here you should have A. You should have either A or B. Here also you can have either A or B. Okay, this is how you have to draw the diagram. Okay, this is how you have to draw the diagram. And now we are making this as the final state. Okay, we are making this as the final state. Okay, this is how you have to draw the diagram for the given problem statement. Okay, I hope you understood the problem. We'll see the remaining thing in the next lecture. Okay, thank you.